Right, so now we're going to look at what happens when something burns. All right. We said that it is a reaction with oxygen. So a lot of the times, especially with metals, you're going to end up with an oxide being formed. And in a little while, I'm going to show you a video clip of when magnesium burns in the presence of oxygen. So we'll have a look at that in a second. So what we're looking at today now is this idea that when something burns, and so let's just look at this equation of the magnesium, right? So magnesium plus oxygen, it's the one we used actually in the previous little section on mass equations. But so we've got magnesium and oxygen, and it gives me magnesium oxide, all right? And so obviously that's going to be 2, and that's going to be 2 in order to balance them. Okay, so that is the basic equation of magnesium reacting with oxygen. So this would be in the presence of heat, all right, enough heat to actually cause ignition. All right, and so for that one, we use the Bunsen burner to create enough heat for that. All right, so that would be our fuel. There's the oxygen and creates magnesium oxide. All right, so this idea of a substance reacting and bonding, chemically bonding with oxygen, is created an oxide. Another typical example of this would be rust. When when iron is outside, all right, so, for any length of time, especially then in conjunction with water, the water acts as a catalyst, which we learned about in the previous section. A catalyst, something which speeds up reaction. So iron plus water with oxygen causes rust, which is iron oxide. So that reddish color that you always see on rust. It's the same thing with the Nemo, right? There's copper clad, right? So there's copper on the outside, so it should actually be this shiny copper color, but because of the reaction with oxygen, with water as well, it grows that sort of greeny color. It's the reason why the Statue of Liberty is also that same greeny, bluey color, right? So that's copper oxide. Copper and oxygen chemically bonded together to create an oxide, right? And in some situations, it actually protects the actual metal underneath. So the copper oxide actually protects the copper from actually breaking down. It's the same that occurs with aluminium. So aluminium oxide, again, creates this protective layer over the actual aluminium so that it doesn't actually break down and actually degrade. Iron oxide, on the other hand, does cause corrosion, and it does actually break down. Okay, so that's what an oxide is.